for this semester, for your life also. First thing that I would like to say is that try to be punctual, because that is very important. And what we do is that if we have the class to start at 11:30, we take it as 11:30. Now, if we do it like this, that the class is at 11:25, and keeping that in mind, if we arrange ourselves, then it will be, we can many times avoid this type of delay. Like, suppose you try to get up in the morning, you give an alarm bell, and suppose you put up the alarm at 6:30 in the morning, and in your sleep, what you do is that at 6:30 when the alarm bell rings, you think, okay, I am having still 5 more minutes of time. I can sleep for 5 more minutes, and again you can keep it in a snooze mode, or you can stop it, and then maybe more than 5 minutes you sleep, and ultimately you become late. So when we set an alarm, we should be very careful about that thing. That is it really the time that I must get up? If that is the thing, then I must get up. And if I see that at 6:30 is not the time, I can still sleep for 5 more minutes, then why not put the alarm at 6:35 itself, rather than putting it 6:30 and then taking 5 more minutes of time? That is not necessary. Keep the alarm in such a way that after that there is no way you can sleep like that. So like that, we should try to develop ourselves into a way where we can think about what we are doing to ourselves, rather than thinking about what others are doing, the politicians are doing, everybody else is doing, rather than thinking about myself. Let us try to criticize our own action, and then if you do it, then you'll see that we can minimize our own faults. And that is very important actually, to find out the fault, self fault finding, and then trying to rectify it. Merely finding the fault will not also help. That becomes a kind of a mental problem. So that will be with an intention that we rectify ourselves so that we can minimize those things, and that will be helpful for us in the long run. That is the main objective. That how to keep ourselves trouble free. So for those things it is necessary. That is one thing that I'd like to tell. Another thing is that regarding the class, nowadays I tell something about my own life. So I'd like to begin again with that thing, that when I was a student, I was not so serious about all subjects equally. And then I went to industry, worked there for some time. Then I found that that place may not be suitable for me. So I tried to come back desperately to academics, and then finally I could come back. And then after a few years of my teaching career, around say 7-8 years afterwards, I started doing some amount of consultancy work for industries. And that started exactly 26 years back. I am into the, also parallelly with this teaching profession, I am also carrying out extensive amount of industrial consultancy. And that I started in the year 1995. And in the first job that I took up along with two of my colleagues, one colleague, he left in between. And then the whole thing came upon the shoulder of one myself and another of my colleague. And it was a very challenging and very difficult job. And for that, we took longer time than what was expected to be delivered. Finally, we could finish satisfactorily. And during that time, I noticed that whatever has been taught, many of those things, they are coming in a remote way, not directly. Some things are coming in a direct way, some things are coming in a remote way. And let me give you a glimpse of that problem that we tried to solve for an industry. I am not naming that industry. No, they make some kind of a structure that looks like something like an almirah, and in almirah and steel almirah, inside there is an electrical component for voltage regulation, and they are one of the monopoly supplier of this equipment. they tried to reduce the weight of those structures. It was essentially a structural mechanics job, and we took it because I found that it is necessary for us to be a complete mechanical engineer rather than being a specialist in particular field like thermal or maybe fluid or maybe machine design or maybe manufacturing. It is not like that. Nobody will give you a job that will come in a standalone way. The jobs that you have to tackle will be in its totality, and nobody will give us the job involving 10%. In fact, that is why we work in a team over here with professors from mechanical engineering department, electrical engineering department, sometimes civil engineering department, and we work in a team. We have a team. Now, when I started doing that thing, that structural engineering job, then I found that some part of this radiative heat transfer was also involved there, some part of convective heat transfer also involved there like that. So what I would like to say is that do not apply your judgment to think that one subject is more important and another subject is less important. One subject is theoretical, another subject is so-called practical. Subjects are never can never be categorized like that. So you cannot categorize subjects like more important, less important, like theoretical, practical. I keep on saying one thing, that there is nothing called a theoretical thing and a practical thing. Any theory that has no practical application is not at all a theory. Theories are there only to be applied in practice. So this type of categorization and then keeping something in the higher pedestal and keeping something in the lower pedestal, that is a foolish act on our part. That we do out of our immaturity, out of our lack of proper information. If we, when we know more and more things, we'll see that everything is important. There is nothing less, nothing more importance is there. So the moment we start taking something lightly, actually that thing goes away from us. So you should take everything with equal seriousness. That is my request to you. It is not for a concern out of my subject I am telling. For anything that you are supposed to spend time on, give it do it with your full attention. Do not lack in your attention, because you never know, after some time, after maybe 5 years, that may be the job that you are expected to do, and then you will find that you have not learned that thing properly. So again, you have to read, and again, at that time, you may not have anybody around, you may be alone. That may be a good thing to learn and read things alone, but the time that is allocated now is the time. Why don't you spend that time for that purpose so that you can apply it in future? So take every subject seriously. And since then, this 95, we had been in heavy amount of consultancy activity. And to tell you very frankly, a large chunk of my daily time, that may be sometimes around 70 to 80% of my time, goes into this work of industrial consultancy. And that you can do because of our theoretical background. And this involves job from many different disciplines. Even within mechanical engineering, you'll see that this is a very vast area. It has five broad specialization. Within that, you have numerous subjects. You may wonder why we learn all those subjects. In fact, the time that is available is short, and it is becoming still shorter because of incorporation of many interdisciplinary things. So for you, the time is becoming really very squeezed out, and do not spend any time in a wasteful way. Use all your time in a fruitful way so that you can enrich yourself. Because enriching yourself will be giving you the strength. Otherwise, what will happen, will suffer from a constant fear of losing something. The moment you become knowledgeable, there is no end to it. But when you feel that you know things, you become confident, so fears will go away. But if you know that you know less, that is always true. We never know everything in its totality. We know very little. But whatever little we can learn, if we try to attempt ourselves to learn, then it will give you some satisfaction, it will give you some strength, and that strength will allay all the fears from your life. Most of the fears in our life, they come from our own inherent weaknesses, because we know ourselves what we do. We may tell many things to others, but we know what I am doing. So I cannot hide myself from myself. So we should try to be honest with ourselves. We should give all due time to whatever is assigned to us, and learn with total respect anything that comes your way. Another thing that we do is that we apply judgment that this subject is boring, that subject is very attractive. Take everything with equal seriousness. Maybe one teacher like me may not be capable enough to teach you in a good way, but if you try to avoid me, it will not be good for you. So whatever inefficient way or efficient way I can deliver my things, you interact. Even if I do something in a bad way, try to rectify me. If you cannot do it, try to tell it in a whatever way you like. Teachers should like to also know what are their drawbacks, where they are lacking, what is their lacuna in terms of teaching. So if it is a free and frank discussion, then everybody will improve out of that thing. I for myself not I am not afraid of any kind of criticism. If you have something, tell me. I'll never mind that thing. Okay. But try to be honest with yourself. Try to devote your time to whatever you are learning, whatever is in the curriculum. I have deep respect for people who develop this curriculum. Now something is happening. The part of the curriculum is coming from the central agencies, and that is sometimes not to my honest liking. But mostly when we are developing our own curriculum, that thing is really born out of many hours of discussion amongst teachers who are very experienced in different fields. So they try to develop subjects and curriculum that will be really helpful for many of us. So with these few words, we'd like to start this class. And another thing that I'd like to say is that there are always indication that because of changes in the global scenario, other fields are becoming more attractive. This field is becoming less attractive. What will happen? A day will come very soon, again, where the days of mechanical engineers will be very much sought after, because most of the people are running away from this. So there will be very few people. And if you are one of such people, knowledgeable man, then you can be really a man who will be most sought after by the industry. So try to develop yourself in such a way that you can really serve in interest of the university, and then in turn they will serve your interest. It is a kind of a mutual thing. If the industry sees that you are a resourceful person, then they also will try to take care of you. And if they find me as a burden on them, then they will not take me with any amount of seriousness. That is the thing, that if I can deliver what is expected of me to the industry also will take care of me. So for that, I need to be all knowledgeable. Do not confine yourself only to whatever the things are taught and whatever is not covered. Don't skip those things. Try to learn the subject in its totality, in its whole. That is the thing. So with this, I'd like to now go into this class. The class is about the subject. Name of the subject is heat transfer. So what is heat? You know from the definition of thermodynamics, is a form of energy that crosses the boundary of a system by virtue of temperature difference across it. It is a form of energy which is in transit, that appears at the boundary of a system, and this energy is distinct from another form of energy that can cross the boundary, that is known as work. And there are many other similarities. Both are kind of path function. They depend on how the process is undergoing a change of state. Depending on that, the amount of energy that crosses in form of heat or work, that changes. So it is a path dependent function. This is known, is a temporary kind of thing, that nobody possesses this type of energy in heat form or in work form. No system possesses energy in the form of heat or work. It is a form of energy that is evident only during a change of state. It is a very transient form of energy. It is not a permanent kind of thing that remains within a body. That a body does not store heat, it stores energy. But when that energy crosses across the boundary, it may cross either in the form of heat or work. These are boundary phenomenon, these are transient phenomenon, these are energy in transit, these are path function, these are the similarities. You also know the dissimilarity between heat and work, that heat is a lower form of energy, inferior form of energy, and work is a superior form of energy. In the sense that we can convert work in its totality into heat. But if we want to convert heat into work, only a part of that can be converted into work. The residual amount will be rejected out of the system in the form of heat. So we cannot convert heat fully into work. A partial amount only can be converted into work. And what is the maximum amount of conversion possible? That is given by something like a Carnot engine or something like that. On the other hand, work can be converted fully into heat. So these are the things that you have learned in thermodynamics. Now, whatever you have learned in thermodynamics, it has its own jurisdiction or boundary, and every subject has a limitation. It has a potential of application. Also, every subject at the same time has a boundary, and the limitation is bounded by that boundary. There is always something more. Now, what is something more that is not covered in thermodynamics and that we will cover in heat transfer? That now I am going to tell you. That heat transfer is a subject that bothers about the rate of heat transfer. That when a body rejects heat or when a body accepts heat from outside, heat is a energy in interaction between the system or a body along with surrounding. Now, the rate at which this energy interaction in the form of heat takes place, the rate of energy transfer, that is what is being covered by the subject of heat transfer. And if you see consciously the subject of thermodynamics, it does not tell you how to find out the rate of heat transfer. It talks about that if a body is at some initial condition, if the body goes to another final condition, and that transfer from condition 1 or state 1 to condition 2 or state 2, if you know the path of that transition from state 1 to state 2, if you know the change of state at each and every intermediate point, that is, if you know the process of that change of state, then you can find out the magnitude of energy that leaves. But how fast or how slowly, that is to say that what is the rate of heat transfer per unit time, that the subject of heat transfer does not discuss within its purview. It does not fall within the purview of the subject of thermodynamics. For that, this subject heat transfer is being introduced. The scope of this subject is to find out for any change of state or for any given situation, what is the rate of heat transfer between the interacting bodies or particles. The rate of heat transfer is, if it is to be determined, then you have to take recourse to this subject of heat transfer. So it is actually a subject that deals with the rate of heat transfer, nothing else. And for that, if you see consciously the properties that we deal with in thermodynamics, and if you see the properties that we deal with in heat transfer, they have one fundamental difference. The difference is that if we look into the properties that deal with thermodynamics, specifically the properties that we deal with is pressure, temperature, volume, mass, internal energy, enthalpy, entropy, specific heat. all these things, if you look into, one thing is missing in if you see the dimension of these properties, if you see the units of these properties, you'll see one particular dimension is missing, that is time. There is no property in thermodynamics that deals with something like per second or per minute or per hour. So the time thing is not present in the properties that are discussed in the arena of thermodynamics, because thermodynamics does not bother about the rate of exchange. It bothers about the total quantum of energy exchange. The magnitude of energy that is being exchanged, that is only what is dealt with in thermodynamics. But if we want to know at what rate this transfer is taking place, so many kilojoule per second, or so many kilowatt means kilojoule per second, or so many megajoule per second, or so many joule per hour, whenever we try to know what is the rate of heat exchange, that because of that, those things, that limitation of thermodynamics, it does not deal with. So this subject, and accordingly you'll see that in this subject we'll now introduce about properties involving materials, properties which are specific to the materials, or properties which are specific to the situation. We'll see that we have to introduce quantities. Some of them are properties, some of them are physical quantities, other we'll see that in those quantities, that per unit time, per second or per hour or per minute is there. Like, because it is not that you are learning this subject for the first time. You are learning this since maybe, I don't know when, maybe 5, 6, 7, 8, 9, 10, 11, 12, all these years you are studying all these subjects. And that is another dangerous thing, is that the depth, the apparent depth at which you learn in your class 11, 12, that is quite awesome. And you'll see that the depth that you cover there is enormous. But the danger is that when you study so many things in depth within such a short time, then it really doesn't settle in your body. If you have to learn each subject with so much of depth that even a graduate course do not intend to, what happens is that they just go through your body, and no part remains in your body as a permanent memory. You learn and then you forget. You learn new things, then you forget, like that. But what is necessary to work as a professional, you must absorb the knowledge and then you can apply those knowledge. And when you class 10, 11, you don't have any liability to prove to anybody, to apply anything to anybody. Your only proof is how to get marks. You don't have to solve a problem for industry. You have to solve a problem to get good marks. Okay. Now,
Sir,
please.
sir, I think you can start recording. আপনি মনে করে দিতে বলছিলেন।
Okay. Recording. Today the net is slow, so it is trying to start recording. Let me wait. It is just going around that thing recording. Let us start, actually, because what I am telling today is kind of an introductory thing, but important as well.
Yes, sir.
Like that, still it is not recording. Like what I am saying is that the properties that now it is starting. Now properties that we deal with in thermodynamics, they don't have any connection with time, kind of directly, and they don't involve per second kind of thing. On the other hand, the properties that we'll be dealing with in this subject of heat transfer, like thermal conductivity. The unit of thermal conductivity is watt per meter Kelvin. Now the moment this watt comes, that is basically joule per second, energy per unit time. So the unit of thermal conductivity is joule per second per meter Kelvin. So that per second remains, and it is this property that actually governs the rate of heat transfer. And similarly, you'll see other properties like kinematic viscosity, which has a unit of meter square per second, thermal diffusivity, which also has a unit of meter square per second. These properties, they will come into picture in the subject of heat transfer. So you'll now, if you see consciously that this subject will involve properties, most of which will be having a per unit time kind of thing, because they are the property which will govern how fast heat transfer will take place or how slow heat transfer will take place. That's why there is a need for a separate course involving a particular form of energy transfer, particularly heat transfer. The rate of heat transfer is the subject matter of interest for this subject on heat transfer. It is the subject is dealing with the rate of heat transfer. Now, if we want to find out what is the rate of heat transfer in a given situation, then we have to identify what type of situation we are actually dealing with. By that, what I mean is that this heat transfer, this subject of this phenomenon can take place in more than one way. And we know from our previous knowledge that heat transfer can assume one of the three different forms or three different mechanisms by which we can have heat transfer. That is, one form is heat conduction, another is heat convection, another is heat radiation. So heat transfer can take place through one of these mechanisms or simultaneously with more than one of these forms of mechanisms. Let me repeat once again. Heat transfer can take place with either of these three mechanisms of heat conduction, heat convection, or heat radiation. Now let me present to you one such write-up where we show schematically the different mechanisms of heat transfer. And it is not that in all cases one particular mechanism will come into play. There may be a situation where more than two mechanisms can simultaneously play a role. There may be a situation where three mechanisms all can simultaneously happen. Let me present that thing. Can you see it clearly, or I require to enlarge this thing?
Yes, sir, we can see this.
Now in this slide, we are trying to show the different modes of heat transfer. They are conduction, convection, and radiation. Though these are known to you, let me reinforce it once again. It's like
Sir, sir, please full screen it, sir.
that is what I am trying to do. Is it enough for you?
Yes,
If
sir.
I full screen,
No, it is good enough.
Yes,
good
sir.
enough, but the problem is that if I do it like this, then width-wise it is okay, but the full picture is also necessary. Let me scroll it up. Now, whenever you talk of energy transfer, there is a source point and there is a destination point. That energy goes from one to another. That energy goes from a system to a surrounding. A system, we can call it as a source, and surrounding is a destination kind of thing. On the other hand, if a body receives heat from the surrounding, then surrounding is the source and body or system is the destination. So just a kind of a allegorical thing or similar type of thing we have brought into a situation that there is this barn that is on fire, and people are trying to douse the fire or extinguish the fire by taking water from this well. So the source of water is at the well and they want to target it to the barn. So there is a target or destination and this is the source. Now you can transfer this water in three different ways. One way can be that people stand in a queue, in a kind of a queue, and one man picks up the water through a bucket from the well. He transfers the water to the next man. He transfers the water to the next man like that. And finally, this man he throws the water from the bucket into this place to extinguish the fire. And while doing this thing, the individual persons who are transferring this water, they are not shifting their position. They remain in their mean position. They may have some movement here and there, like when they are trying to collect it from the man on the left, he may be bending towards the left, and when he is giving the water to the man on the right, he may bend somewhat towards the right. But he assumes or occupies a mean position, and that is at this position. And then he may have slight amount of swinging left and right like that. So here what is happening, the individual carriers, they don't move in their position, and the transfer is not because of their movement, rather they hand over, they take it something from the previous man and delivers it to the next man like that. So whoever is the source, from him it takes, and whoever is in the receiver's end, he gives it like that. So there is a potential, or there is a direction in which this is moving. It's not that it's coming from the right towards the left, but the source point is being on the left, is moving from the left towards the right. So this is how the water is being transported, while the individual carriers, they are not shifting their mean position from their mean position. They may have certain amount of sway or oscillation at their respective mean position. Now this is something similar to our method of heat transport by heat conduction, where the particles of a body, they don't move from their mean position. They may oscillate about their mean position, and while oscillating, they are coming in contact with the neighboring particle. From there, a more energized particle is handing over the heat to a less energized particle. But the particles, they are not shifting from their position. They don't have any bulk motion about their position. Now, I have used one term, that is a more energized particle is handing over the energy to a less energized particle. Now, how do we identify that more energized particle and distinguish it from a less energized particle? Is by looking at some other manifestable characteristics, which is also having we can assign some value to that. That is what we call it as temperature. That is a property. A specific property, a particular property, which in a way indicates the amount of energy that a particle carries. When a particle carries more energy, it is more agile, and it has more amount of vibratory nature, more amount of local kinetic energy. So it is vibrating more, and then it's trying to give the energy to the next layer or next particle, where the energy level will be low, such that the temperature is low. So a higher temperature particle is trying to give the energy to a lower temperature particle like that. And that is how the energy is moving from that source point, which is on the left, to the target point, which may be on the right. And there is a definite direction in which the energy is being transported, that is from particles at higher temperature to particles at lower temperature. So the energy is moving, while the carriers of the energy, they remain more or less fixed at their mean position. Only they have some local vibrating oscillatory motion, and that is similar. This way of conducting energy is known as conduction, and that is what is being shown schematically in this mechanism. Now there may be another way. Apart from that, if there may be a situation where energy can be also transported individually by somebody from the source point, and he can travel all the way up to the target point to deliver the water. Now when he does it like that, when he carries the water, we call this mechanism as convection mechanism. He is convecting energy. So One thing we discussed is conduction, where the individual particles they do not travel, whereas in convection, the particles they may move from source up to a destination point. The source is characterized by a high energy content, which in turn is manifested in form of their high temperature, and the target point may be at a lower temperature, indicating that they are suffering from energy. So the energy has a tendency to go from a high energy content point to a low energy content point, and this conveyance is taking place physically by the conveying particles. And when it so happens, we call it convection. Now again, convection has two different ways of or reasons for such movement. This movement may be there may be two different causes of this movement. One cause may be that there is an external thing which is forcing this motion, like when you are supplying water in a pipeline, when you are supplying water in a pipeline with the help of a pump. Now, some part of the pipeline, if it is heated, then the water which is momentarily in contact with the heated part of the pipeline, water will pick up energy from the pipeline. Then because it is moving, because of it is being forced by a pump, then that energy which is picked up by that water from the hot part of the pipeline, that water is not stationary, that water is being forced forward. So what happens is that when the water travels forward in the pipeline, along the pipeline, it ultimately comes in contact with another part of the pipeline where the temperature of the pipeline surface is lower. So what will happen? The water is picking up the energy from a part of the pipeline which is heated, and then when it travels along the length of the pipeline, it ultimately comes in contact with another part of the pipeline where the temperature of the pipeline is not so high. It may be in fact lower than the temperature of the water. Then what will happen? Then the water will try to deposit part of the energy onto the cold part of the pipeline. So what is happening? Energy in this case is traveling through the water, which is the conveying medium, by convection. Now this convecting motion, the cause of this convecting motion is because it is being pushed forward by a prime mover like a pump. So then we call it a forced convection. On the other hand, think of a situation that you have a pipeline or you have a pot of water which is being heated from the bottom, and the pot is kept on a gas oven. Suppose you have placed a pot of water on a gas oven, and then you light up the oven. So what will happen? The bottom part of the pot will receive heat from the gas, burning gas. So that part of the pot will try to get heated up, and then the water which is in contact with that part of the pot, আমি একটু পরে কথা বলবো, একটা ক্লাস নিচ্ছি, হ্যাঁ পরে কথা বলছি একটু পরে। So the part of the pot which is heated, that will transfer the heat to the water. Then the water which is now heated and which is at the bottom, and the water at the top part of the pot, that is not so much heated. So now what will happen? The bottom part of the water which is heated will have a lighter density, and the top part of the water which is not heated, which is at a lower temperature, that will have a higher density. So what will happen? The lighter density water will be feeling a force of buoyancy. So it will try to move upward because of the buoyant force. It will receive a force upward. So it will move upward, and that part of the space may not remain vacant. So what will happen? The water from the neighborhood, which is not so high temperature, that will try to fill up that space. So what is happening? The hot water the lighter density water at the bottom is moving upward, and the colder water, which is having a heavier density, that is trying to fill up that space left by the hot water, upward moving hot water. So in this way, there will be upward motion by the buoyant fluid, and there will be downward motion from the more heavier, colder fluid. So a constant circulation will take place. Now you see, this circulation is not set up by any external agency. You don't have any pump because of which the movement is taking place. You don't have any starter because of which you don't have any starter because of which there is a motion. The motion is taking place because of a natural phenomenon known as buoyancy. So whenever there is a heat transfer, there is a temperature gradient, and because of the temperature gradient, there will be always a density gradient. And whenever there is a density gradient, favorable density gradient, that is, if the lighter density is at the bottom, then it will try to move upward. Why I am telling this favorable density gradient is that if it is just the opposite, that you are hitting the water from the top, and the bottom water remains colder, then what will happen is that even though the top water is heated, even though its density decreases, but the lighter thing is at the top and the heavier thing is at the bottom, then there can't be any buoyant force to cause the motion. So this motion will take place when you have a heating on the bottom, and the bottom part of the fluid will become lighter, so it will move upward. And when this type of motion takes place, is called a natural circulation or force or free circulation or buoyancy induced circulation. This is not a forced circulation. A forced circulation means something where the fluid is being forced by an external agency like a pump or a blower or a compressor or a stirrer, or by some physical surfaces scraping the air, not like that. So if the motion is because of some external agency, we call it a forced convection. If the motion is due to no such external agency, but because of the natural phenomenon of buoyancy, we call it a natural circulation or free circulation or buoyancy induced circulation. And the corresponding convection phenomenon, the corresponding transport of heat because of movement of the fluid as a whole, movement of the fluid itself, not as a whole, movement of some part of the fluid itself. If that fluid is energized, it will try to transport the energy from a more energized spot to a space, to a point where the fluid is not so much energized. So that is how it will try to equilibrate the energy. And this motion is causing the transport of energy, motion of the fluid, and this motion is due to buoyancy. That is why this convection is called free convection or natural convection or buoyancy induced convection. So convection may be of two types. One is free convection or natural convection or buoyancy induced convection. There may be another type of convection that is known as forced convection. Now there is a tricky thing about this thing is that what I said is that natural convection is because of density gradient, and that is because of temperature gradient. Now if you think of heat transfer is a phenomenon that takes place when there is a temperature gradient. So whenever there is a heat transfer, the heat transfer takes place because of a temperature gradient, and the heat moves from a high temperature region to a low temperature region. So always there is a temperature gradient from the source point towards the target point in a decreasing temperature gradient, and the heat flows in the direction of the decreasing temperature gradient. Now, so there must be a buoyancy gradient or density gradient also along the direction of the decreasing temperature gradient, where normally the density will be higher at the lower temperature region and the density will be lower at the higher temperature gradient, and it will try to move from a region of lower temperature towards the higher temperature opposite to the direction of gravitational pull. It will have only one direction, that will be opposite to the direction of gravitational pull. The gravitational pull will be downward and it will try to move upward. Now, when I say there is forced convection, and I am telling that forced convection is because of an external movement. Now, can we think of a forced convection situation where the movement is only because of an external agency and there is no natural convection? That is something that may not be possible all the time, because whenever there is heat transfer, even if it is forced convection heat transfer, it is true that the movement is taking place primarily or prominently because of a pump-like situation, a pump-like device. A pump is causing a movement. But superimposed with that, maybe there is another movement, another part of the component of movement that is also being aided by the density factor. For example, if I take a vertical pipeline and the water is being pumped upward, it is being fed from the bottom of the pipeline and taken out from the top of the pipeline, and you are hitting the lower part of the pipeline. Then what is the reason for which the water is moving upward? Can somebody tell? Suppose there is a pump fitted at the bottom part of the pipeline and it is forcing the water upward. At the same time, the lower part of the pipeline is heated from an external source, so that the heat is being picked up by the lower part of the water and the water is moving upward and delivering the heat to the upper part of the pipeline. Now, this movement, if you examine, can you tell why this movement is taking place, the water movement upward, why this is taking place? Can somebody tell that why this movement is taking place?
So we are heating and
Density gradient.
both
One,
So because of the temperature difference.
here,
Density gradient.
here the movement can be ascribed to both the factors, because there is a pump, so that is trying to move it upward, and because there is a heating at the bottom part, so there is a buoyancy force at the bottom part that is also moving, causing a movement upward. So where here in this example there is a superposition of both the causes which are causing an upward movement. Now, if the buoyancy component is less or negligible, then we can call it as a forced convection. Okay. Now, if you stop the pump, then what happens? In the same problem, now you stop the pump, then also there will be a movement upward. Then
Yes.
the movement upward will be because of buoyancy only, because you are no more using the pump. So if there is water in the pipeline, because of buoyancy, it will try to move upward. So this movement is because of purely natural convection. But if you have a pump, then the upward movement may be because of both the factors simultaneously occurring. The pump factor, which is trying to cause a physical movement, forced convection, and the density gradient is trying to make a natural convection. Then we can call it a combined convection. When both the factors are equally prominent, then that upward convective motion, we call it as a combined convection, combined forced and natural convection. But if the natural convection component, the contribution of the natural convection component is negligible compared to the forced convection component, then we can tell that it is a case of a forced convection. Although, honestly speaking, there is always, in this example, there is always a natural convection. But when the natural convection is much less, contribution of natural convection is much less than the contribution of the forced convection, we call it only a forced convection. Though natural convection is present, it is not zero exactly, but it is negligible. So we can have situation where there is only pure natural convection, like the pump is not running. But if the pump runs slowly or the velocity produced because of pump is not so high, so that the force convection is moderate, also because there is a sufficient amount of temperature gradient so that the density gradient is sufficient, then both may be equally contributing, both may be equally significant. None of them can be negligible. In that case, we will call it as a combined convection. But if the contribution of the natural convection becomes negligible and contribution of forced convection becomes significant, we call it forced convection. There may be pure natural convection where there is no forced convection. There may be pure, can there be in this example, can there be a pure forced convection? It is not truly speaking pure forced convection, but you call it forced convection because the natural convection component may be negligible. When something is negligible, we don't unnecessarily complicate that phenomenon bringing into picture because the contribution of that is negligible. So to simplify the problem, we can eliminate that factor out and can consider this as a case of a purely forced convection. But when the contributions are equally significant, we cannot, for the sake of simplification, we cannot eliminate one factor with respect to the other. Then we may introduce too much of error. So to keep it enough accurate, you have to consider both the factors. When both are equally strong, then we call it a combined convection or you call it a mixed convection. Combined in the sense that is combining forced and natural convection. Mixed convection in the sense that is combining forced convection and natural convection. So we can have three different possibilities of convection. One can be natural convection when the force component is negligible. We can have forced convection when the natural convection is insignificant, and we can have combined convection when the contribution of both are equally significant. Now, this significant, insignificant, these are qualitative terms. We require to introduce some numbers with respect to which, in a quantitative sense, we can neglect one over the other. So in our next class, we'll try to go into somewhat further detail, and then we'll start the actual. So today I have spoken enough because if I speak continuously, my throat becomes very tired. So for today, I'd like to stop.
Sir,
And please,
sir,
if you have any,
can I ask?
yes, if you have any question, you may have hundreds of questions. Please ask me now. I
Sir,
don't want to continuously, but if you have as many questions you ask, I'll be happy to answer that.
So initially there was no liquid like in this pipe. So initially we have to just keep the pump just to force up to the top face of the pump. Then the convection will be forced convection or the natural convection. That is what you are trying to say.
No, can you state the problem fully? Initially, you have talked about the emptiness of the pipeline and
Yes.
gradual filling of the pipeline. What about the heating part? That also initially was there or not?
But that was so initially was not there. It was
I'm talking of the dissimilar heating of the pipeline. What we are taking is that suppose the pipeline, lower part of the pipeline is heated with the help of some kind of a localized heating, okay? And the upper part of the pipeline, there's a heat sink type of thing. So this is an example of a particular device known as heat pipe. Heat pipes run on the basis of this principle. Even boiler pipes are like that. You are heating part of the pipeline and thereby the water is moving upward. Now, you repeat your problem and then I'll discuss.
does it mean that in this process the pipe is filled with that liquid which we are taking?
No, you state your problem fully, then your statement cannot start from does it mean. You restate the full problem without any ambiguity, first of all. You repeat your question once again in totality. If you don't think that you have stated once, so you need not to state it once again because there will be some incompleteness in the statement. We also have to develop a habit of completing our statement so that nothing remains unstated. Please repeat once.
Initially, the pump has to give the force from the source to that heat sink to complete the I think to complete the pipeline flow, and then the convection will start. Like the natural convection, the fluid will flow, or the forced convection, it will be flow. That is in this way. Will this what you are telling like this?
Now, question is, the pump is meant for pushing a continuous flow in a pipeline. Okay. Pumps we use for making a flow to take place. So there is a pump is running. We are talking of a situation. Let us first of all make things simplified, that we see the picture when it is in a steady state of operation. Okay, something is running continuously. That will make us simplified. And then what you are trying to bring in is a very good thing. That is what happens during the startup phase. During the initial starting up phase, what happens actually. Okay.
Yes.
It's a very good thing that you have raised, and interesting things we can discuss. Now, again, similarly, when you stop a device, there is shutdown phase. What happens? So, for any device, there are three phases. If you ask me a question, I will not give answer yes or no kind of thing. So, I expect a elaborate question, and I would also like to give you an elaborate answer, because in the process, when you ask me some question, many different thoughts come, and I'd like to take that opportunity to share with you those thoughts. Just giving an answer, yes, no kind of thing, maybe a partial satisfaction, but if we exchange our ideas, then more than that, it may be known to you, which may not once again appear throughout our lifetime. So it is better to deliver as soon as we get an opportunity. Now, in any device, there are three phases of operation. There is a starting up phase of a device, then there is a steady state running phase of a device, and then there may be a shutdown phase of a device. Now, in some devices, the startup phase and the shutdown phases may be very short-lived, and the steady state of operation is a very long, prolonged phase of operation. Like if you see a power plant boiler, a power plant boiler is lighted up once in maybe 10 years, 15 years like that. When you set up the thing, when you start it for the first time, you start up the boiler. Then it runs continuously. You do not shut it down because of two things. One, you require continuous power supply from a power plant, so the boiler has to continuously generate steam. Secondly, when you start up, when you heat up, the things tend to expand. So not only the pipelines are supported by some other structure, big work, and all those things are there. So everything gets heated up. And when everything gets heated up, they have different coefficient of thermal expansion. So different components have different tendency to expand because of a inherent property of material known as coefficient of thermal expansion, and also because of the fact that different part of the device are at different temperature. So they have different amount of temperature rise. That also causes different amount of expansion, thermal expansion. So different parts of the same component or different location of the same component may have different amount of thermal expansion because of different values of coefficient of thermal expansion, the property, and also the different points have different temperature. So because of these two factors, different parts they tend to expand differently. So what happens is that because of a differential expansion, there is a generation of something known as thermal stress. Even if you don't have anything, if you heat up this type of thing, then what will happen? The bodies will develop different amount of thermal stress, and that may develop some kind of gap, some kind of crack, some kind of failure can take place. And also the life of the device will get down. If you have a cyclic loading on any device, maybe it may be a mechanical loading, unloading, It may be a thermal loading, unloading. You are heating up and then cooling down, heating up and then cooling down. So what will happen? It will try to expand and contract, expand and contract. And because of that, there is something known as fatigue failure will take place. So the devices will be subjected to fatigue failure. And these are things that do not operate at moderate temperature. They may be heated to something like, say, 700, 800 degrees centigrade. And when you cool it down, there is a huge amount of thermal expansion and contraction. And the parts, they may tend to become separated out. There may be leakages may develop. So what is done is that the pump, once a boiler is heated up, it remains like that for a long period of time. And compared to that, the initial startup and the final shutdown phase is nothing actually. It may take a few days to light up a boiler to a steady phase. It may take a maybe few weeks to cool down a thing, but the operating part of a boiler may be years after years. So different things have to be taken in different contexts. Now, if we think of the major part of the operation that is under steady state, then what is happening is that continuously the pump is running, continuously the heaters are heating, and continuously the heats are extracted from some other point like that. So that part is simple. That's what you are not talking of. What you are talking of is the initial phase when you are supplying the water to the pipeline, when you are starting the heating up this thing. Okay. Now, even if you come to this point, normally what is done as a practice is that in a pipeline, you do not heat up until and unless the whole pipeline is filled up. In a boiler, there is something called a superheater. Are you aware of that thing? In a boiler?
Yes, sir.
Now, what happens in the boiler? There is a drum where the steam is generated. But that in the steam drum or the pipelines where the water is converted into steam, there the steam can never be superheated because it is in contact, it is in two phase. So when in the container where the steam water is in two phase coexistence, the temperature cannot go beyond the saturation temperature. Now you may require a superheated steam. So what you do is that you take that saturated steam into another pipeline where you supply further heat to heat up the water, the steam from saturation temperature to superheated temperature. That is done in another part of the pipeline known as superheater. Now what happens is that when you start up a boiler, the superheated tubes, they don't receive any steam. So they could remain vacant. Now, if you heat up the superheated tubes when there is no such steam or anything is there to take away the heat, then there is something called a burnout will take place. The tubes will become damaged because of it is receiving so much of heat, but there is nothing to take away the heat. That is called burnout. So the practice is that even the superheated tubes, when you start up the boiler, you fill up the entire structure with water before you start heating. Okay. So that question will not arise over here. The practice is that you fill up the water, you ensure that the whole thing is filled up with water. Not much of air pockets will be there. The whole thing you have to prime, as known as priming operation. So you fill up the entire thing with water and then you start heating. So that question is not actually, it may be a theoretically attractive question, may have certain complexity what you are talking of, but the practice is that first you have to ensure the whole thing is filled up with water, be it with a pump or gravity, whatever the way, and then you heat it up. So when initially you have only forced convection without any heat transfer, that is all a convection, but that is isothermal convection. You are merely passing through a pipeline water, like your drinking water pipeline, water is flowing. So that is also water convection. Now when you heat up, then heat transfer by convection takes place. But by that time already the water is flowing because of forced convection. And then when you heat up, it may accelerate the flow because of natural convection superimposed on forced convection.
Okay, okay, sir.
Any other question is there?
Sir, in case of natural convection, is there any condition on Is there any limitation on the man number 3 to return back to the well?
Is there any limitation on? Can you please repeat?
In the figure, there is man number 3. Is there any limitation to return back to the well in case of natural convection?
Acha. Now, because it cannot be like this. The man means everything in nature is filled up. So what will happen? If no supply, then what will happen? This place will dry up, so no convection will take place, first of all. So what happens is that normally what we see in our experience is that although there is an upward movement, now so this place appears to be becoming like a vacant space, but nothing in nature will be like that. So long as it has some supply from some other point, there will be flow from a neighborhood, so that space will be filled up. So it will be a continuous kind of thing will happen. Otherwise it will be a once through kind of thing. Okay. So there is a continuous circuit, a movement forward and some movement backward from a colder region to this place. So that is why there will be continuous convection of heat also. So what is happening? Some particles are moving away from the heated region towards the colder region. So those particles, they are taking away the heat, and simultaneous with that, there will be a continuous flow of liquid from the or fluid from the colder region that will tend to fill up that void, and this whole phenomenon will go on taking place continuously so long as there is a supply of this thing. So if there is, it is not that it is a once through kind of thing. So it will be a once through heat flow. If you want to sustain the heat flow, you have to have a continuous supply of particles from this point to this point. So where from it will come from the neighborhood, where from it will come and go. Like if you see the road in a summer condition, you see in a summer the roads become very heated. The air that comes in contact with the road, that will become buoyant, it will move upward, and then what will happen? The air from the neighborhood, which is not so heated, will fill up that space, and that will in turn become heated. It will move upward. So this phenomenon will happen continuously. It is not a discrete thing, one man, two man kind of. It is a continuous flow of mass in one direction, and there must be a makeup of mass from another region where the temperature is low. The fluid will come here, and then it will take place like continuously. It will be completing some kind of a circuit continuously.
Sir, this cycle is convection too.
Can you repeat?
Sir, this similar type of cycle will be present in forced convection too.
There has to be a continuous flow, otherwise there can't be a continuous forced convection. You have to supply continuously cold water. It may not come from the same region. It may come afresh from some other external source. Like in your say boiler, you are supplying a continuous water maybe from some source, or maybe from in a closed circuit. If it is a closed circuit, then there is a recirculation. If it is an open circuit, then you have to have fresh supply. Like in a closed circuit boiler, it comes from the condenser. Through a condensate pump, it goes to the boiler. The same water which has passed through the boiler again comes back to the boiler. There is a recirculating type of thing. But you can have a situation where there is no such closed circuit. There may be like in a gas turbine. What you are doing, like in an IC engine, what you are doing is that you are supplying air fuel mixture, air from atmosphere, fuel from your fuel tank is converted into heat, then heat has many roles to play, so finally reject. So to run the engine continuously, you have to have a continuous supply from air from atmosphere, continuous supply of fuel from fuel tank, then all the engine can run in a sustained way. So it depends on the application. It may be a closed circuit application where there will be a kind of a cycle, theoretically a cycle is being completed. If it is an open kind of thing like an IC engine, they are a mechanical cycle, but truly speaking, a thermodynamic cycle does not take place.
Okay, sir.
Now let me make a roll call and then we can. Rishabh, I have taken your classes previously in drawing class, so I know many of these names up to. Rishabh is present or absent? Rishabh Dhaliwal.
Yes, sir.
Rishabh is
Yes,
present.
sir.
Acha, Jishnu,
Present, sir.
Abhishek Kumar Mishra,
Present, sir.
Sahil Singh,
Present, sir.
Shobhik Chaudhary,
Present, sir.
Kaustubh Ghosh, Kaustubh.
Present, sir.
Is it Kaustubh or Kaustubh?
Kaustubh.
Kaustubh. Somnath,
Present,
Somnath
sir.
Ghosh,
Present,
Ashutosh
sir.
Raj,
Present, sir.
Sheli Dে,
Present, sir.
দুটো কতগুলো আওয়াজ একসঙ্গে বেরোচ্ছে। সোমনাথ আশুতোষ শেলি দে প্রেজেন্ট। দেন
Yes, sir.
রায়ান ঘোষ,
Present, sir.
অরিত্রায়ণ।
Present, sir.
অরিত্রায়ণ, তোমার পরে তোমার আগে 65 রোল ছিল চক্রবর্তী, কি নাম, সৌম্যদীপ চক্রবর্তী। হ্যাজ হি লেফট দিস কোর্স?
Yes, sir.
আর ইউ শিওর হি হ্যাজ লেফট?
স্যার আমাদের সাবসেকশনে যে সৌম্যদীপ ছিল সে লিভ করে গিয়েছে।
70 অর্ঘদীপ,
Present, sir.
গীতদীপ,
Present, sir.
মধুসূদন অ্যাবসেন্ট, মোহাম্মদ আসিফ,
Present, sir.
নাফিস অ্যাবসেন্ট,
Sir, Madhusudan is present.
মধুসূদন ইজ প্রেজেন্ট।
Yes, sir.
আচ্ছা, মোহাম্মদ নাফিস ইজ অ্যাবসেন্ট, ইজ ইট? এন্ড ইমন
Sir,
কল্যাণ
sir, Mohammad Nafis, I think, will not continue.
আপাতত কয়েকটা দিন এরকম করি, তারপর ওটাকে করতে হবে।
Yes, sir.
Yes, sir. পরে আবার এডিট করে দেবো।
ঠিক আছে। আর ওয়াহিদ ইমান কল্যাণ,
Yes, sir, present.
ঈশান মন্ডল, ঈশান অ্যাবসেন্ট, বিশাল রয়,
Ishan was present. Sir, I am present. Vishal Roy present. Ishan was present.
ঠিক আছে। জাভেদ মুস্তাফিজ অ্যাবসেন্ট, ইমতিয়াজ আলম অ্যাবসেন্ট, আব্দুল ওয়াহিদ,
Yes, sir. Present.
আব্দুল ওয়াহিদ প্রেজেন্ট। এই কি বলতে কি হয়ে গেল, দাঁড়াও। প্রেজেন্ট। রাহুল সরকার, কল্যাণ কঙ্কন রায়,
Present, sir.
Sir, Rahul Sarkar is present.
আচ্ছা, শান্তনু মন্ডল, সুতৃষ্ণ প্রামাণিক,
Present, sir.
সুতৃষ্ণা,
Yes, sir.
শান্তনু অ্যাবসেন্ট,
Yes, sir.
অনির্বাণ,
Present, sir.
উৎকৃষ্ট পোড়েল, উৎকৃষ্ট নাকি
Present, sir.
উৎকৃষ্ট বলো না উৎকৃষ্ট বলো, কি বলো?
Utkrist, sir.
উৎকৃষ্ট, যীশুখ্রিস্টের মতো আর কি।
Yes, sir. Yes.
রবিন, রবিন বালা ইজ অ্যাবসেন্ট, সপ্তর্ষি অ্যাবসেন্ট, প্রীতম
Present, sir.
প্রেজেন্ট।
Present, sir.
আচ্ছা, আকাশ,
Present, sir.
আকাশ প্রেজেন্ট, কিংসুক,
Present, sir.
মৃত্যুঞ্জয় অ্যাবসেন্ট, ঋষিকেশ কুমার
Present, sir.
সায়ন্তন
Present, sir.
সায়ন্তন প্রেজেন্ট। এই তারিখের ক্লাস নিচ্ছি, তারপরে ফোন করবো। হ্যাঁ, মিনিট 15 পরে। কিরণ কিরণ হেমব্র,
Present, sir.
সৌম্য হেমব্র, আকাশ কুমার সিং অ্যাবসেন্ট, মৃণাঙ্ক সরকার,
Present, sir.
এরা আমার যে মনে পড়ছে ল্যাটারাল এতে ছিল না মৃণাঙ্ক?
That's a weird system.
Readmission, sir.
আচ্ছা, সৌম্যদীপ অ্যাবসেন্ট, ইন্দ্রনীল,
Yes, sir.
অয়ন চৌধুরী অ্যাবসেন্ট, কৃষ্ণ মিত্তাল,
Present, sir.
প্রতীশ কুমার,
Present, sir.
দৈপায়ন পাল,
Present, sir.
দীপন চক্রবর্তী,
Present, sir.
সৈয়দ ইনায়েত আলী অ্যাবসেন্ট, শুভঙ্কর বিশ্বাস,
Present, sir.
অনরণ্য দাস অ্যাবসেন্ট, সৌম্যদীপ ভট্টাচার্য।
Sir, present আছে, মাইক্রোফোনের প্রবলেম হচ্ছে।
আচ্ছা, কে ওই অনরণ্য?
না, সৌম্যদীপ ভট্টাচার্য।
সৌম্যদীপ। আচ্ছা, প্রীতম মিত্র প্রেজেন্ট করা আছে তোমাকে। প্রীতম মিত্র অ্যাবসেন্ট, আমান রাজ মোতা,
Present, sir.
সন্দীপ কুমার সাহু, দীপ্র ব্যানার্জি অ্যাবসেন্ট, অর্ক বেরা,
Yes, sir. Present, sir.
সৌহার্দ্য রায়,
Present, sir.
সৌপায়ন রানা,
Yes, sir.
অনন্য ঘোষ অ্যাবসেন্ট, ঋষভ হরি,
Present, sir.
ঋষভ ঘোষ অ্যাবসেন্ট, তাপস মন্ডল,
Present, sir.
হ্যালো, প্রেজেন্ট?
Present, sir. Yes, sir.
ঠিক আছে,
Sir, Orko Bera is present.
হ্যাঁ বলো আরেকবার।
বলছি স্যার অর্ক বেরা is present.
অটোবেরা তো মনে হয় করা হলো কি? অটোবেরা প্রেজেন্ট করা আছে। অটোবেরা প্রেজেন্ট।
Okay, okay.
অ্যাবসেন্ট হচ্ছে ঋষভ ঘোষ, অনন্য ঘোষ, দীপ্র ব্যানার্জি, প্রীতম মিত্র, তারপর অনরণ্য দাস, সৈয়দ ইনায়েত আলী, তারপরে হচ্ছে অয়ন চৌধুরী, সৌম্যদীপ মন্ডল, আকাশ কুমার সিং, মৃত্যুঞ্জয়, শান্তনু মন্ডল, ইমতিয়াজ আলম, মোহাম্মদ জাভেদ মুস্তাফিজ, মোহাম্মদ নাফিস, are present otherwise.
Yes, sir. Yes, perfect.
পরের দিন কবে আছে ক্লাস? ফ্রাইডে, মানে তোমাদের যে মানডে, টিউসডে, ফ্রাইডে, ইজ ইট লাইক দ্যাট? ঠিক আছে। আচ্ছা, মানডে, টিউসডে কবে কখন আছে? মানডে 10টা নাকি 11টা, কটা আছে? মানডে 1টা থেকে 2টো, টিউসডে হচ্ছে 10টা থেকে নাকি? আচ্ছা, আর ফ্রাইডে? ঠিক আছে, ঠিক আছে। তারপরে তার পিরিয়ড কি আছে? কারণ কি অনেক সময় হচ্ছে কি আজকাল সব দেরি ফেরি ঘুমিয়ে টুমিয়ে এমন হচ্ছে, সে 2টো 3টে বেজে যাচ্ছে কাজ করতে করতে। তোমাদের আমার যে পিরিয়ডটা 10টায় আছে তারপরে পিরিয়ডটা কি ফাঁকা আছে না ফাঁকা নেই?
হ্যাঁ
স্যার
স্যার
কবে?
যেদিন 10টায় আছে অর্থাৎ টিউসডে আর ফ্রাইডে।
অ্যাকচুয়ালি রুটিন অনুযায়ী স্যার ক্লাস রয়েছে,
ঠিক আছে
আমরা
ঠিক
গ্যাপ
আছে
করতে পারবো।
ঠিক আছে। না ওই ক্লাস আছে, ওটা তো আজকে হচ্ছে না, হয়তো পরের দিন থেকে হবে, এরকম একটা ব্যাপার আছে।
হ্যাঁ এক্স্যাক্টলি।
ঠিক আছে, থ্যাংক ইউ ভেরি
ওকে
মাচ।
স্যার, থ্যাংক ইউ সো মাচ।
স্যার থ্যাংক ইউ স্যার
Thank you, sir.
Thank you, sir.
Thank you, sir.
If you